Hey everybody, Dr. A here, and in this video we are going to be discussing some of the basics of structural engineering. So to get started, let's discuss structural analysis. So structural analysis considers how forces and moments are transmitted through structural members. So whenever you have a structural system, maybe it's a truss, maybe it's a beam, a frame, that is supporting applied forces, applied loadings, structural analysis looks into how those applied loadings that are acting on a structure are transmitted into the structural members and then transmitted from one structural member to the other, all the way down to that structure's either foundation or support system. Okay, so that's structural analysis, and usually structural analysis involves a lot of calculations that come from statics and mechanics of materials. Okay, now we also have structural design. So what is that? So structural design entails the sizing of members. So that includes cross-section selection. Let's spell that correctly. To support the internal forces and moments that are determined from analysis. So when we think of structural design, we commonly think of maybe a class in steel design or a class in concrete design, wood design, masonry design. So again, structural design uses information from the analysis process to determine required sizing, sometimes required lengths of structural members. And when we say structural members, we mean things like beams, braces, truss members, maybe shafts that are experiencing twisting or a torque. Okay, so these are two different attributes of structural engineering, but they work together. So it turns out that analysis and design are iterative processes that work together. Okay, so they go hand in hand, and in a real life structural engineering project, you often have to perform some analysis procedures, perform some design procedures, and then reiterate and re-perform some analysis checks, and then maybe refine your design. So this kind of goes back to the idea of applying the engineering design process that you may have learned about in a previous course in engineering. Okay, so let's briefly talk about some of the common structural design philosophies. So common structural design philosophies include allowable stress design. Let's change colors here. Allowable stress design, which we often abbreviate ASD. Okay. Now, in ASD, this is usually a philosophy, a design philosophy that you were exposed to maybe in a statics or mechanics of materials course. ASD is based on inserting in a factor of safety into your design process. Factor of safety can be used to reduce the strength, the theoretical strength of a member's material, or it could be used to artificially magnify or inflate the applied loading acting on a system. So that's ASD, and again, you've maybe been exposed to this in a mechanics of materials course, maybe a statics course, maybe a structural analysis course. A second common philosophy is called load and resistance factor design. And we abbreviate this LRFD, okay? Now, in LRFD, this is based on some more sophisticated probabilistic and statistical analyses that account for uncertainties in material properties in some of the design theories and fabrication and construction practices. So in LRFD, we don't bundle up our uncertainties into one number like we did in allowable stress design. So in LRFD, we're going to talk a little bit more about this right now. So let's change colors here. In LRFD, we typically apply load factors, which are applied to service loads. Service loads are the loads that are directly acting on a structural system. And these load factors are usually larger than 1.0, okay? So what we do is we have these load factors that are larger than 1.0 that we apply to the expected loads acting on a structure, and we increase them, we magnify them. So these are called load factors, okay? And then we also will apply resistance factors to theoretical member strengths, which are usually less than 1.0. So resistance factors are applied to the theoretical member strengths, and what they do is they decrease the theoretical member strength. So resistance factors could be, 0.7, 0.8, 0.9. It depends on the type of member you're looking at, and it depends on the limit state you're interested in. But again, what they usually do is they decrease the theoretical member strength. And again, both of these two types of numbers, load factors and resistance factors, are developed through sophisticated probabilistic and statistical analyses, okay? Now, a third design philosophy which we encounter sometimes is called plastic design. Now, plastic design is not used as often as LRFD or ASD. Plastic design basically assumes that your material behaves in what's called an elastoplastic manner. And so what you look at is you have a linear stress-strain relationship in the early stages of material behavior and loading, and then your stress-strain diagram transitions to an infinitely long horizontal segment, okay? And so, again, the whole premise of plastic design is based on that kind of behavior. And plastic design, we encounter it sometimes in practice, but what's much more often to encounter is LRFD, and then probably followed by ASD. So that gives us a quick overview of structural engineering as it pertains to how we analyze and design systems and how that process kind of interacts within itself throughout an engineering design process. So thank you for watching, and if you like this video, go ahead and hit like and subscribe, and look out for some other helpful videos to you in the future.